Good morning, Geometry Honor students. So Mr. Chen again. So just want to talk about that the continuation of chapter 7. Okay, so let's take a look at that for this page right here. So proving that the quadrilateral, it's a parallelogram. So the way to prove that quadrilateral is a parallelogram, so we do have the following statements. Okay, so one of the conditional statement is true. That means we can prove that the quadrilateral, it's a parallelogram. If a quadrilateral has an opposite side parallel, then the diagram, it's a parallelogram. If a quadrilateral has opposite sides congruent, so therefore the quadrilateral, it's a parallelogram. If a quadrilateral has opposite angles congruent, and also the diagram, it's a parallelogram. And number 4, it's a quadrilateral has a diagonal bisecting each other, so therefore the diagram, it's a parallelogram. So basically we're using that the property or the special properties of a parallelogram. And also number 5, if a quadrilateral has angles supplementary to the consecutive angles, so therefore it's a parallelogram. And number 6, so one more statement, okay, if quadrilateral has a pair of opposite sides congruent and parallel, then it's a parallelogram. Okay, so this one, got to be careful with that. So besides that, it's being the congruence for the opposite side, but also it shows that they're parallel. Okay, so now let's look at that, the proving statement and also the two-column proof. So let's go back up to the top right here. So there are like lots of proof that you guys can do for this page. So again, so the statement, you can fill in the blank, so the one that we just go through. And also perhaps you can start with the warm-up problem here, the one that we did for the previous lecture. Okay, so analyzing a diagram in A to E, the given its marked on the figure. So tell whether each quadrilateral ABCD it's a parallelogram. So this one shows that the opposite sides are parallel, so it is a parallelogram. So this one, just check that off, it is a parallelogram. And then this one shows that the opposite sides are congruent. Yeah, it is a parallelogram. And then the opposite angles, they're congruent, so this one is also a parallelogram. And this one shows that the diagonal bisecting each other, it is a parallelogram. Now, got to be careful with this one. Is this one considered parallelogram? This one only shows like one pairs of sides of parallel, but also at the same time, it shows that those two sides are congruent. It is a parallelogram by using one of those conditional statement, the one that we just go through. So now let's get into a little bit more in depth. So based on the marking, decide if each figure is a parallelogram. So justify the answer. Again, this one opposite side, so they are not congruent. So this one, no, it's not a parallelogram. This one shows that the pair of the interior angle. So this one alternate interior angle, they're considered congruent, but we're not sure about the other opposite angle here. So this one, no, not enough information. And then this one here shows that the sides are opposite, so they're what, parallel, and also they're congruent. It is. So angle bisects each other. Well, this diagonal, they're bisecting each other, and also shows that the vertical angle, yeah, it is a parallelogram. And this one here just shows that one of the diagonal, it bisects each other, and the opposite sides, they're congruent. So this one we cannot state anything. Okay, so this will be no. And this one also alternate interior angle, they're congruent, just one pair. Opposite side, they're congruent. And this one, let's see. Yeah, this one is a little bit tricky because once you prove that those two triangles congruent, so we can use angle side. So once you prove the triangle's congruence, we can state that the other segment here, they're also congruent as well. And also this two line segment, so they bisect each other. So technically this one, yes. And then opposite sides of the line segments are congruent, so yes. And then alternate, well, this one opposite angles, they're congruent, yes. Still, the next one, so state whether the information given about the quadrilateral rand it's sufficient to determine that it's a parallelogram. Okay, so angle RDC, so angle RDC is congruent to NAC, and then angle ARC is congruent to angle DNC. Okay, so this one, and let's see. In order to prove this one, it's considered a congruent triangle. So technically this one, it's not enough information. So just showing that it's alternate interior angle. So saying that those two, they're like transversal. So this one, no. Okay. So what about 11? So this one showing that RD. Okay, let me use different color here. So showing that RD, it's congruent to AN, RN, and it's congruent to RA. Yeah, this one you cannot say that they're congruent, so this one doesn't make sense. So only showing that the opposite sides are congruent, and saying that the diagonal is actually congruent to one of the line segments of a parallelogram, so it doesn't make sense. So both of them will be no. So this one's no, and also the previous one will be no. And then let's see what else. Okay, let's just erase all those marks. So the next one is saying that ACN, angle ACN is congruent to angle RCD. Okay, so the vertical angle. So RCA. Okay, so RCA is congruent to angle DCN. Okay, so this one is showing that the vertical angles, they're congruent. Okay. So now let's see if the vertical angles are congruent. Yeah, also this one, it's not good enough information to say that it's a parallelogram. And the reason why that is because we're not sure about the line segments there. Okay, we're not sure about the line segments. People might be saying that using the angle side theorem. Okay, so angle side theorem, so that's the one using for the isosceles triangle. Okay, so people might be saying that, well, this one, the opposite side or the corresponding side would be congruent. Technically, they are, but the thing is that we're using it for the isosceles triangle. So this one, we cannot say anything like that. And then the other one, so RD. So segment RD is congruent to segment AN, and then RA is congruent to DN. Yeah, opposite sides are congruent. Yes. So this would be yes. Okay, so now let's see what else that we have for the rest of this. So the proof. So quadrilateral ABCD, so diagonal AFEC. Okay. So DE is perpendicular to AC. So AF is perpendicular, well, DE is perpendicular to AC. So this one forms 90-degree angle. So BF is perpendicular to AC. And then AE is congruent to CF. Okay, so this line segment here is congruent with this line segment. Okay, let's put the mark like that. And then DE, okay, so DE right here is congruent to BF. So you want to show that ABCD is a parallelogram. Okay, so in order to prove that it's a parallelogram, so one thing that we can stay here by using, okay, so started with a given. So one thing that we notice, So since we do know that DE is perpendicular to AC, BF is perpendicular to AC. So one thing that we notice, okay, so the given, so I just put in ditto from the given statement. So we can state that triangles BFC and triangle AED, it's a right triangle. Reason, definition of a right triangle. Well, the reason why that is because those two line segments are perpendicular, so that means it forms 90-degree angle. So therefore, it's a right triangle. So this one is a right triangle. Another thing that we notice, so this one can be proved by using psi, angle psi. Okay, so triangles BFC is congruent to triangles AED. And the reason for that one, so statement number 3, and it's proved by psi, angle psi. So by using psi, angle psi, so another thing that we notice, so AD is congruent to BC. And the reason for that is because that's CPCTC. Okay, so here's another thing that we notice. So this one's saying that DE is congruent to BF. Okay, so DE is congruent to BF. Okay, we use that already. And now let's prove this triangle here. It's also a 90-degree triangle. So those two right triangle here. So another thing that we can stay here, so can we use that the hypotenuse and leg? We wish to use that, but no, this one it doesn't work with the hypotenuse and leg. Oh, here's another thing that we can stay, the segments. Okay, so segments AE minus segment FE, which is the same as segment FC minus segments FE. So this one you can say that it's a segment subtractions postulate. And then one thing that we can say here, so AF is congruent to EC. So this one is by definition of congruent segments. So once we prove those two line segments are congruent, so the other two triangle here, so we can use that psi, angle psi theorem or postulates to prove that triangles AFB is congruent to triangle DEC. Okay, so let me just add one thing on. Actually two more statements, two more reasons. So therefore, segments AB is congruent to segments DC or CD. Again, CPCTC. And by using this two statement here, statement number 5, statement number 9, so we can say that ABCD, quadrilateral ABCD, is a parallelogram. Definition of parallelogram. Okay, so this one is like a 10 statement, 10 reasons proof. Okay, so the other one is quite similar. So once we showed that, either the opposite sides are congruent or the opposite line segments are parallel, or the vertical or the opposite angle are congruent, so we can just say that ABCD is a parallelogram. So that's something you guys can try. Okay, so let's try one more problem right here with this one. So ACDF, it's a parallelogram. So ACDF. Okay, so the overall picture here, it's a parallelogram. So AFB, okay, AFB is congruent to ECD. Okay. So we want to prove that FBCE, so the small quadrilateral, it's a parallelogram. So in order to prove this one is a parallelogram, so one thing that we can state here, okay, so definitely we can prove that the opposite angles, so the opposite angle would be congruent, okay, this two angle right here. Another thing that we can state, okay, these two angles, they're also considered congruent as well. So this one is, it's not a long proof, it's actually pretty straightforward, because one thing that we notice, ABCD is a parallelogram, ACDF, so this one is already a parallelogram. So which means that angle AFD, okay, this angle here, and the entire angle, and then angle ACD, they're congruent. And this one is by using the properties of a parallelogram. Okay, so another thing that we notice, the measure of this angle, well, the measure of angle AFB, which is the same as the measure of angle FBC. And also on the other part right here, on the other side, so angle ECD is the same as angle FEC. And the reason for this one is because that two line segments are parallel, so therefore the alternate interior angles got to be congruent, alternate interior angles. So this one is by using definition of alternate interior angles. So for statement number 3 and 4, it's the same reason, definition of alternate interior angles. So therefore that angle FBC is congruent to angle FEC. And this one using definition of congruent angles. So now, another thing that we notice for this angle right here, by using angle subtraction postulate, so we'll get angle EFB, so the measure of angles AFD minus angles AFB, so you'll get angle BFE. And also for the other side right here, similar, so angle DCA minus angles DCE, so you'll get angle ECB. So again, we just want to prove that the opposite angles are congruent for the small parallelogram. So this will be using angle subtraction postulate, and therefore angle BFE is congruent to angle ECB. Definition of congruent angles again. And therefore, statement number 9, so we can just say that quadrilateral FBCE, it's a parallelogram. So this one again, you just want to say that if opposite angles are congruent, then the quadrilateral is a parallelogram, or just by using the definition of a parallelogram. It's one of those properties. Okay? So now let's see what else that we have for this. Again, this one is just like what we were doing. So anytime that we find out the conditions or the diagrams which can satisfy one of the condition here, so that means the quadrilateral, it's a parallelogram. Okay, so this one is more in-depth proof. So you're more than welcome to try any of this. So given that quadrilateral JKLM, it's a parallelogram. So PX is congruent to QX, and you want to prove that the inner quadrilateral JPLQ, it's a parallelogram. So it's quite similar to the one that we did. Okay, so here's another one. So given that the outer quadrilateral, it's a parallelogram, so the line segments are congruent, and you want to prove that the inner quadrilateral, it's a parallelogram. Okay, so there's a lot of examples that you guys can try for any of this. Okay, some of those are saying that's bisecting each other, or angle bisector. Okay. Alright, so that's it. So I'll see you guys next time.